Multicellular critters are the things we see. And so they're more familiar to us. And in that way, because we can see them so clearly, they're really, really freaking cool. I love this. I'm just a nerd, right? I love this infographic that I found where it divides. It's like a giant Venn diagram, right? Where you have unicellular critters and multicellular critters. And then you have this like overlap of archaea, bacteria, protists, plants, animals, and fungi. And you can see who's single-celled and who's multicellular. And I'm going to tell you right now, archaea and bacteria, these are colonial multicellular critters. These are not actual true multicellular critters. And I'm going to show you a video to see if we can capture, I think this is, no, not that. There, this is it. To see if we can illustrate the difference between colonial multicellularity and like real, authentic, I'm a multicellular critter, because if you try to take my individual cells apart, they're most likely not going to make it without all of the other cells. And as I say that, I'm like, well, we can take cells out and we can keep them alive in various ways. And that's true, we can. But there's a huge external investment to keep a multicellular critter's single cells alive, right? Whereas this, what I'm going to show you next, is clearly critters that are single-celled, that can survive on their own and then come together to form a multicellular critter, and then can dispel their multicellularity and become single critters again. So first of all, let me tell you the story of these guys. These are slime molds. And homeboy John Bonner studied slime molds when he was an undergrad and took all these amazing videos. So we're going to look at his videos that he took of these protists that, when stressed, so they're single-celled amoeba-like critters that cruise around and do their thing. But when things start to get funky or stressful, they come together and form a slug, like a slug that moves along in slugly form, like squishes away from where the stressful thing happened. So if food runs out in their environment, they all will get stressed because they start to get hungry. And that triggers a chemical message to have them all come together and form a slug. Slug up, boys, it's time to be a slug. So they all come in and they form a slug and go away from the stressful stimulus. And as they go away, they're like, okay, awesome. We slugged up and we got away from the stressor. Now it's time to make babies. And then as the slug turns into a fruiting body, like a reproductive structure, some of the individuals become stalk and others become like the fruiting, like mushroom thing at the top. And then the ones at the top are going to reproduce. The ones in the stalk die, but at least somebody got to reproduce, and then everybody carries on. And they all had to work together in order to get away from the stressful stimulus that happened in the first place. What? Okay, I'm gonna play this video and I will try to be kind of normal. There's the slug. What? This is like, come on now. There is music that goes with this, but I am not showing you the music. But those are slugs. Yep. And here okay, awesome. It talks a little bit. Those are the individuals. These are the individuals that have the stress and then produce chemicals that cause individuals coming together to form the slug. Look, there they go. There they go. The doo-doo hit the fan. It's time to slug up. Here we go. We're slugging up. They're forming the slug. This is fantastic. Carry on, boys. Keep on becoming the slug. And then self-sacrifice. Because the ones who become the stalk are game overed. Watch this as they become there. Look, the slug grows into a fruiting reproductive structure. Making babies is worth it for the ones in the stalk. They're not passing on their genes, but they're like, it's worth it because they're related, I guess, to the ones at the top. They saved the ones at the top. What? Are you kidding me right now? That is colonial multicellularity. There he is. Dude, how cute is he? He's so proud of his work. That's super awesome. Okay, so think about that when every single one of our groups where we're headed next, plants, fungi, and animals, we have a protus, a single cell eukaryote that is the sister to an entire group of wildly diverse multicellular critters. I love biodiversity. Oh, okay. I'll see you next time. Bye-bye.